Ktor. Ktor is a web application development framework, pretty much like the Spring framework already is. We are going to see in this video how can we implement our first Ktor application, its functionalities, and how can we use dependency injection with Coin, and how can we access databases with Exposed. But why do we need Ktor, and why in a world filled with web application development frameworks like Quarkus, like Jakarta, like Cumulus Enterprise Edition, like the Spring framework of course, why do we need now to choose yet another web services application development framework? To understand that, we need to go back into the past to 2003 when the first release of the Spring framework was done. In that year, there were also other releases of the Java programming language. And through the years, the Spring framework has evolved with Java to be better, to be more complex, to be more efficient, to have more functionalities, and to allow more features to occur. The Spring framework developed to a point that has become a first-class citizen in the world of web application development frameworks. We, in many companies, use the Spring framework to develop our services. And the reason for that has to do with how much the Spring framework has to offer, but also how commercialized it has been. Most companies use the Spring framework, and maybe some other companies use Quarkus, other companies use Jakarta. There are a ton of meetups and sessions and conferences about all of these frameworks, mostly the Spring framework. Even they have a Spring I/O conference that basically revolves around the Spring framework. And this has been a common standard up until 2011, where things seem to start to get a different direction. And that was, of course, with the announcement of the Kotlin programming language by JetBrains. Kotlin was not released yet in 2011, and the first release came in 2016. The first official production-ready release was available in 2016. But Kotlin presented other challenges. And the challenges were, how can we adapt this language now to our web application development frameworks? How can we use it, namely with the Spring framework? And how can we get everything to work with it? Because Kotlin also offered another advantage, and it was using Kotlin coroutines, something that Project Loom was trying to offer as well, with the same features under a different name, called what we now know Java Virtual Threads. But Kotlin was first in creating that kind of implementation, that kind of continuation version, that kind of way of working with threads. And from that, there was a need from the Spring framework, as an example, to improve their application in a way that would offer support also to use Kotlin coroutines. And that's why we now have reactive applications that use Kotlin coroutines, that use Project Reactor with Kotlin coroutines. But that also presented another interesting point, and that was that if we need to use the Spring framework with Kotlin coroutines, we need to use these libraries, we need to use these plugins, we need to make several changes to our application in order for everything to work, which can feel cumbersome. It can feel sometimes very sloppy, and sometimes, again, we are falling into that realm of magic. Because Spring offers a lot of magic as well. As we have evolved in the developer community, we have seen in many different teams that work with the Spring framework that when we are talking about making the application and we are going through our daily challenges, it is not unusual to see developers looking for everywhere on the web and Googling, going to Stack Overflow, and I think currently people go more often to AI to check with ChatGPT, or check with the Copilot, or check with other different kind of assistants that try to find solutions to their problems. But fundamentally, the problem behind it, and why we call Spring magic, and why we use that kind of as a joke, but also as a kind of statement to explain what we are going through, the reason why that happens is that the Spring framework has become very complicated and very complex. And to understand it really well, one of the things that is important for us to do is also to study it to a lot of depth. I had to do that because I am a VMware Spring Professional, a certified VMware Spring Professional from 2021. And I had to make the exam. I had to study for the certification. The exam can feel incredibly complicated. It's very difficult to pass. And I had to study from all kinds of sources that I could find so that I could achieve that and be able to pass the exam. An important thing here is not exactly the course I took to get into the exam and books that I've read to get to that exam. This is Reactive Spring by Josh Long, just one example of books that I had to read so that I could get past that exam. Now, but today Spring continues developing, and that means that as we go along in the future, the energy that I've invested to study the Spring framework is not going to be enough to know everything about the Spring framework. So let's not make any mistake here. What I know about the Spring framework helps getting there, but it's not the answer to everything. And so the point here basically is that the Spring framework has also become complicated. And the reason for that is also to do with the fact that the Spring framework uses a lot of annotations. If you have worked with the Spring framework, you immediately know what I'm saying. There are different kinds of levels of complexity that are there when we are using the Spring framework. For example, one simple trap that many developers fall into is when we are trying to start the application and somehow some beans are not picked. And we take hours, days sometimes, to try and figure out what is going on. One of the things that I saw a lot happening is that while developing Spring applications, many developers are not aware that where you put the application, the actual executable of the Spring Boot application, that determines where the auto-scanning occurs. So things like auto-scanning can be misleading to developers because it's something that we should know before we start developing Spring applications. It's a very simple thing, but it can make a huge difference because if we are inheriting libraries, for example, that contain beans that we want to be auto-scanned, and they are in different packages, not sub-packages of where that application file is, then they won't be scanned, which has led to a lot of confusion, especially if you have a multi-dependency project where you are using different dependencies and you want everything to work very well. And this is just one small thing that really has taken a lot of time in many teams to figure out, to understand, and to solve. Just because you can't just get Spring out of opening a new project and started doing experiments with it. You will get to some point, but after that, you really do need things like this. And you also need to go to the sources. You also need to go to the Spring IO website. You need to check the documentation and read it and see how all of the different entities and types and everything works together so that we can get the Spring framework to work correctly. And all of this just to make the point that people who developed Ktor wanted to make a framework that was fairly simpler in comparison to all of these other frameworks. And so they did. That's what we got with Ktor. A service application that is implemented without the use of annotations. And also, it is a framework that has less overhead when you compare it with things like the Spring framework. It is not to say that the Spring framework is worse than Ktor. It is not to say that we should now all use Ktor. But it is one important point of the development of Ktor. And Ktor was also developed also to be able to provide direct support to Kotlin. Spring Framework was developed around Java, then later it offered support to Kotlin to be able to provide dependency injection in Kotlin, and also Kotlin had different kind of rules because of course Kotlin, I've made this video over here about the Kotlin mysteries, which are in great part related to how the Spring framework works and how annotations work specifically. So go watch that video because it's really important so that you understand a kind of complexity that Kotlin wasn't quite able to solve yet. And it has to do with the shifting paradigms between Java and Kotlin, which contributed to the idea of creating this alternative framework. What I want us to do now is to go through 8 potential benefits of using Ktor as an alternative to using the Spring framework. It's not to say that you always have to pick up the Ktor framework instead of the Spring framework. This is something to consider when you are starting a new project. But one of the things that you need to keep in mind is if you are using Kotlin as your programming language for your service, for the development of your service or web applications, then Ktor can actually be a good alternative for you, because that is probably the most important argument to use Ktor. But in any case, let's go through all of them. So the first one is lightweight and minimalistic design. As we have mentioned before, the Spring framework uses a lot of annotations. It uses things like Spring factories. It uses things like the bean lifecycle, the bean factories lifecycle. It uses all of these listeners that will start with different annotations, the exception management. The way all of that is done can be fairly complicated, and of course we always resort to that word magic, which is something that the Ktor framework wants to avoid. The idea is that we can explicitly define what we need for our application, that we don't have a strict rule, that we are quite free to implement the applications within a certain standard, but it's not a strict standard. But the most important part is that we can still understand our application. So it becomes very lightweight, and potentially also it has less overhead than Spring. But this is something to see later on. The second potential benefit is, as I just mentioned, is Kotlin as a first-class citizen. When we say first-class citizen, we are saying that the framework Ktor will use Kotlin as its preferred language. It will make sure that Ktor stays compatible with Kotlin, but if we are thinking about using other things like Scala, Clojure, Java, anything that is also compatible with the JVM, there probably aren't that many guarantees that it will work well. It is specifically made to work with Kotlin. Regardless, it may be compatible to use in any language of your preference. But Kotlin is the first language that it has focus on. So things like creating objects to access databases and things like that, they will all circle around the patterns that are specific for Ktor and that will adapt very well to using Kotlin. The third potential benefit is that Ktor by default is asynchronous and it works with Kotlin coroutines. If you have been working with the Spring framework for a long time, you know that the Spring framework works in a blocking way. It does not work with coroutines, and that is no surprise because in 2003, nobody was talking about implementing continuations and implementing things like coroutines and making sure that the threads could be shared between different tasks. That was not something that was being used in development. It exists since the 1950s, but it's not something that was used in 2003. It started being talked about and used once the release of the first version of Kotlin with Kotlin coroutines was released. So what this means is that our applications in Ktor are by default reactive. By default, Spring applications are blocking. In Ktor is reactive, which means less use of libraries, less use of external libraries, which in turn results in a simple setup of an application. Because Ktor has been developed with the idea of reducing overhead, it means also that a lot of the different metrics that we use to define if our application is efficient or not are improved with Ktor. There is less overhead and there is less startup times using Ktor because our applications just simply become more simpler. And that means that the native performance and low overhead is something that in Ktor is also improved. Then we have to talk about flexibility and customization. When we are using the Spring framework, and especially with more complex applications, we need to configure our application to work. And sometimes we have different properties, sometimes we have a huge amount of properties, which in this case, this shouldn't be a difference between Spring and Ktor. What is different is how those properties act with the different instances that are running in our context in the Spring application. The idea of Ktor is to simplify the way we configure applications. And we are going to use different ways to configure our application. And we will see that further down in this video. But keep in mind that one of the ideas of Ktor is to provide a more flexible way of configuring our application. This is an interesting one. There is no magic. What Ktor does is, because it eliminates the use of annotations, the idea of magic just fades away. There's no more magic and everything becomes more clear. Magic is a word that we have used in the Spring development environments just because some annotations, we use them, and I think many times developers don't read the documentation because it's also a kind of an exercise to go and constantly read the documentation. And so at the end, we end up using annotations that seem to do something, and then they end up doing something different. And sometimes they end up doing something totally different. Just because they suggest they are doing something, but then the documentation says, oh yeah, it does something completely different. And that is also something that we want to avoid. And this is something that the Ktor framework makes it much more explicit. In Kotlin, we like to use the Kotlin features. And these are things like, for example, the data classes, seal classes. We want to be able to use coroutines, of course. And as I mentioned before, everything is asynchronous. And so coroutines are used massively in Ktor. It's the default way of working with Ktor. But also other things like the way we use lambdas, the way we create functions, the way we can use function literals with receiver. All of that is something that Ktor is ready to give us and ready to use as features with this framework, because of course it has been developed around Kotlin. And that means that compatibilities between lazy inits and late inits and all of that kind of initialization, which if you have been working with Spring and Kotlin for a while, you are already aware that there are some kind of issues that occur randomly with using those constructions. That is all gone with the use of Ktor. And finally, one of the great things about Ktor is that we forget that we need to be concerned about compatibility with other Kotlin related libraries. It provides, of course, support out of the box because it is an application developed around Kotlin. And so external libraries that are very much dependent on Kotlin features are no longer a problem using Ktor. So essentially, we can all sum this up to Ktor is great for Kotlin applications if we want to reduce overhead, if we want to use simple applications, and Ktor comes into the scene to solve exactly these problems. And we are going to see that while developing a simple Ktor application right now in our code. So let's get into it. So this is the project I have developed for our simple Ktor application. The project name is called Spaceship Parent, and it is again located on my GitHub repository under my handler j.Esperancinha. This project has been fully developed in Ktor and it is under development. And the idea here is that we are going eventually to manage a spaceship. Now, the purpose here at this point in time is for us to understand how Ktor works and how can we first start with the application. So talking about starting, the first thing we need to do to start a Ktor application is really to establish the foundations of the project. Luckily for us, Ktor has also something akin to what we saw before with the Spring framework, and that is Spring allows us to create an application from scratch by using their website, which is start.spring.io. We can go right there at this point. So if we go to start.spring.io, we'll find the Spring Initializer website. And here we can establish our dependencies and make sure that we can create our project. But of course, this is not a video about Spring. This is a video about Ktor. And for that, we can just go to start.ktor.io. And we have almost the same thing, different colors, different brand, exactly the same thing to create our web application service. Here we can choose, just like in Spring, the different dependencies we want to use. So for example, in this application, we might be interested in authentication. We can add it. We can add CSRF, for example, if we find it necessary. We can add service send events, which is also very useful when we are implementing applications that are based on Kotlin coroutines. Maybe we want to have event-driven applications. We want to maybe have status, use webjars perhaps, use some kind of compression, cores, and so on and so on. We can choose to add Swagger to it automatically. It will create it from the beginning. And we can also add CSS, free marker. We can use templates for our front end. And we can also use for databases, what we are looking at today, Exposed. We can also add Postgres support, MongoDB, Kafka. If we want everything together, we can do it as well, just as I'm doing here. We can also use queues like RabbitMQs. We can use Coin. This is one that we are having a look at today, and WebSockets, and so on and so on and so on. We can then just download the zip file with the foundations of the project, and we can also configure the artifact name that we want to use for this project. Now, this is, of course, just the start of our application. And of course, we're not creating it now because I have already created it before. When we create our application like this, we will find that the directory structure is a little different than what we are going to see in this application, because I have already changed it and separated things and segregated the classes into different packages. That made sense to me. We are not bound to any specific architecture with Ktor, but we should make an architecture that kind of makes sense to us. And coming from a background with the Spring framework, I felt that this was probably the best directory structure to choose from and the best package structure to choose from. So I've got here config for configuration files, route for routing files. We'll see what's that in a minute. And here we'll have our services. So far, it doesn't seem very different than what we are already used to with the Spring framework. But let's now first see the foundations for this project. And one thing that Ktor does right now is to include TOML configuration files in our project. Well, just one, which will then manage our different dependencies. And let's have a quick look at that. So the TOML file usually is located in the Gradle folder. And here we've got the libs version TOML file. This format is an interesting one because we can configure a lot of different versions of dependencies in different ways. I've got dependencies that I've added afterwards to complete the example and maybe for the future, where I use the actual version, the static number of the version. Others, I use the version reference, where I can then specify that a group belongs to a certain version, namely Coin dependencies, Kotlin dependencies, and Ktor dependencies. But I've got here others like Logback, Postgres, Prometheus, and Exposed. Now, these are all things that are already included in the project, but we are not having a look at all of them. The thing is, TOML file is separated namely in 3 different groups. One is versions, the other one is libraries, and the other one is plugins. And so in versions, we just specify the versions we want to use, very much the same thing with the properties that we use in Maven. Libraries, it's just the definition of the different libraries. We can specify the module complete with the name of the artifacts we want to use and the group where it belongs to, along with the version. And then finally, we can specify our plugins in the same way with the full ID of the plugin that we want to use and the version reference, which we can use the version reference or just the version number. But this is just a TOML file. Now, important is that we see the dependencies that we are actually using. And in this case, I'm using a lot of them because this is a project so that we can learn how Ktor works. And essentially, we are adding all of these different libraries to our project. These are the Ktor libraries. We've got a Micrometer library, and we've got the Coin libraries over here. And then we've got also H2 libraries so that we can work with H2. And we've got the Exposed libraries over here. And then finally, we've got also the test libraries for Ktor and for Kotlin. We also have this Swagger library to generate Swagger automatically for us. We're not going to have a look at that today, but definitely in next videos. So now let's have a look at the source code and see how this is all built. As I've mentioned before, this is not the original structure of the package that we get out of the Ktor start.io page. This is a bit different, but it's important now for us to have a look at how this has been created. So in the beginning, when we start our applications, we get this thing called the databases routing. We get another routing for hello world. It has a different name. It's called, I think, HTTP, just HTTP. And then we get monitoring routing. We've got something related to the Open API, which is this one, the configure HTTP, where we then specify the Swagger URL and the Open API itself, what we want to use for the routing of these endpoints. And then we've got something for security, where we are basically just incrementing the session number. And then here we've got serialized routing, transmission routing, and then we've got the different DAOs that then use the different objects that we want to use. And these objects are created here in the service. This is at least how Ktor generates this first for us. And here we've got, for example, the city, which is then created right over here at the top of the file. Here we can then use the city object to simply just add data to our database. The city example that comes with Ktor uses something akin to the JDBC statements that we use in Spring. It's literally the same thing. We used connection here to simply create statements and then execute SQL queries. The objects here mean very little. The types, the city type and the different properties, name and population, they mean very little because we are actually creating queries with them explicitly using our code. So we are not using anything that may be similar to what we use in JPA in Spring architecture. We are simply here just using these objects literally and create our queries with them. And the libraries that we are using here is simply the Java SQL connection and the Java SQL statement. This is not anything new than what we already use in Spring. The reason I am also mentioning Spring is that sometimes we use these libraries without even referencing or knowing that these are not directly coupled with Spring. They are used in the framework with Spring, but if we are using JDBC statements, they usually end up using these libraries as well. All right, then I've got another one, which is the user schema DAO, and this is where things will be getting more interesting because here, this is where we are going to learn how to use Expose. And Expose has different types. We are having a look at two different ones. One is table, and then we are going to have a look at another type, which is located in another service, which is this one, Transmissions DAO. And the Transmissions DAO will give us the ability to use an int ID table, which in other words means that we are specifying with this type that we want to use an ID in a table that is of type int. And we can look at the definition of it and download the sources very quickly. We can see here at the top that it is a table name, what we want to use. We give it a name, we give it a column name. We give it the column name, which is the column name, which is the name of that ID. And then we can start to create our table. But look at what it says right over here. Identity table with a primary key consisting of an auto-incrementing int value. So here with the single type, we are already saying that it is a table, that it has an ID, and that the ID is an int, and that is also an auto-increment integer. So that is what we've got over here. We can also have a look at the table type that we had in the user schema DAO. And here, if we go to the user type, we see that it's table. And if we check on what the sources say, it says it's a base class for any simple table. If you want to reference your table, use ID table instead. Then we just specify the table name. By default, name will be resolved from a class with table suffix removed if present. And that's what we've created over here when we say that our table will be of type users. That means that we will have a table of type users. That is because if we go over here, we see that the table name is not empty, then it's a name. And then otherwise, if the package is null, then it will use a strategy to remove table from the name. And if it's not null, then it will remove everything and it will just keep the name of the class, and if it has name, it will remove the suffix of that class name. And that's what we've got over here, and that's why the name of our table in this case will be users without having to create the table first. The tables are created when we create the connection to the database, and this is also what we are going to see. So now let's start with the way Ktor actually works. So the way Ktor actually works is by using an executable, and in this case it is very, very similar to the way Spring already works. Essentially, we are creating in the main class, in the main method, we are calling engine main main with arguments. If you know the way the Spring framework works, you know that Spring application dot, I think, run or start, then the type of the class, and then the arguments. That's the way we start Spring applications. In this case, we start with engine main dot main args, which isn't very different. The difference is when this application starts, it will run this module definition. And here we will define the way the Ktor application needs to work. We are going to go through all of these configurations before we even start running the application. So let's have a look at it one by one. The first thing we want to do is to get the content negotiation right. Content negotiation in this case means the type of contract that we have when we make the request and when we get a response. When we make the request, we want to make sure that the request is in the JSON format, and we want the response to be in the JSON format. It could be anything else, but in this case we are using JSON. And this is the way we tell it to work with JSON. And we can have a look at content negotiation. Content negotiation is actually a plugin that serves two primary purposes. It's negotiating media types between the client and the server. For this, it uses the accept and content type headers. Serializing, deserializing the content in a specific format. Ktor supports the following formats out of the box: JSON, XML, CBOR, and protobuf. Protobuf is important because it can be used with JRPC. And this is a way that we have to simply specify that. And as you can see here, we already have a difference, a crucial difference, to be honest, between Ktor and Spring. Remember in Spring where we say it produces, it consumes, and then we specify the application JSON? This is how Ktor can simplify that. It goes to every single request response and it says that we want to make sure that it will consume and reply in a JSON format. Now let's have a look at the configure serialization. Configure serialization is something that also comes with the Ktor demo application, and it is simply a routing for a GET request that will then respond with a map of hello to world. So that means it will respond with the serialization of hello world in a map. So key hello, value world. There's nothing too special here, but this establishes already a route. So each routing that we get here is akin to using a controller in the Spring framework, but it's not exactly the same. It's something a bit different because when we use routing, we establish the different methods. And here we will be able to do different things. We are already inside a suspend function. Let's have a look at that. If we look at here to the get implementation, we see that it is a route. It's not as easy as it normally is to read this kind of source code, but we can see over here that the body that we are implementing is actually a suspend routing context. So this is what we are implementing right over here when we put here call respond map of hello to world. So this is already a huge difference between what we do in Ktor and what we do in the Spring framework. Let's have a look at the next one. The next one is configure security. Now configure security, we can have a quick run through it, but it is important here that we understand that we need to install things when we just start the application. Ktor has that very crucial difference between the Spring framework and itself. And that is that we can install our plugins during runtime. And here we have at the beginning of the configure security method call, this is an extension function of application, we can then see that we install sessions. And sessions, if we go inside of it and check the definition, we can see that it says a plugin that provides a mechanism, a plugin, bear that in mind, a plugin that provides a mechanism to persist data between different HTTP requests. Typical use cases include storing a logged in user IDs, the contents of a shopping basket, or keeping user preferences on the client. In Ktor, you can implement sessions by using cookies or custom headers. Choose whether to store session data on the server or pass it into the client. Sign and encrypt session data and more. So this is how we deal with sessions in Ktor with a plugin called Session. This is the first time that we see in this video how to install or where to install a plugin. So we can see here that we define a cookie being my session, and here we got cookie extension SimSite, and then we call it lax. And then we've got the routing where we are just going to increment sessions. We got session count 1 by 1. And then here we've got the class called mySession where we keep the count of the current sessions. And then a response counter is session count, refresh to increment. So this basically uses a sort of session manager that will use a counter in our cookie to keep the record of how many times we refresh the page or how many times we get to call this get endpoint. The details aren't important for now because of course we want to learn more about the Ktor framework, how it works, and we are seeing that right now, but we also want to see how coin and expose work. So let's continue with our application definition. We have seen the configure serialization, the configure security. Now it's time to check on configure administration. Let's see what can we find in there. Again, an extension function that simply installs another plugin. This time is the application call plugin. And if we look at inside of it, we kind of already have an idea of what it is, but let me just get to the actual definition, and we can see here that we've got an application call plugin, and it simply says an installation object of the shutdown URL plugin. This is basically an endpoint that will allow us to shut down the application, and the plugin facilitates that. So if we go here back to where we started, we can say that we are installing a plugin, and with it we are installing the shutdown URL where we supply the exit code to be 0. That means that we can shut down the application without signaling an error to our system. And this is already a lot before we even start to discuss the topics, the two other topics that we want to discuss in this video, which are coin and expose. Let's see configure frameworks. In configure frameworks, we are going to have a look at something very interesting, which is coin. Coin is a plugin that allows us to perform dependency injection in Ktor. Let's see the definition and see what it says. In coin, if we download the sources, we are going to find lots of authors for this plugin. There is no documentation available in this case. There's no docs available for it, but we can see that it creates an application plugin called coin, and it then starts to do all this stuff. When we create the application plugin, very important to understand is that when we do this, we are already starting coin. Start coin is something that you will find in several documentations as something to start and enable the framework. We don't have to do that when we install the plugin like this. If we don't, then we need to specifically start coin and then perform the other operations if we need. If we don't, we don't have to. But the idea is that once we have installed coin, we can now figure out what we want to install with it. And this is what we do in the modules section of that plugin. Now, we are already saying here that we want an SLF4J logger, but most important of all is that in our module, the first one we create, the first and only we create, because we can create more modules with it, we are saying that we are creating a singleton service called hello service, which is an implementation of this interface here, which only has one single interface method called say hello. This is a sort of functional interface, which you probably already know from Java if you are used to working with Java. And then here we see that we are implementing in that method a print environment log info hello world. What this does, this allows us to use dependency injection just like in the Spring framework, where we then can inject this at different points in our application. Another thing that I'm doing here is I am creating a database connection, and this is with the database object. And what happens here, I'm also creating a transmission service. We will have a look at the service in a minute, but important is that we are creating that service with this database object, and then we are making it a singleton sort of bean. It's a singleton class, a singleton instance, and it will be available at every point in our application. So the fact that we are calling application configure frameworks already means that we are making sure that we are installing coin with all of these services in it. So if we go back, we now have got the configure monitoring. The configure monitoring, I leave it by default because configure monitoring puts a lot of logs when we start our application. We see an endless continuous text being put out into the console, and that can be very confusing when we are trying to understand the application. But I now have enabled it, and we can look inside of it and see what it has. Essentially, it is installing another plugin, and we are already familiar with the way it installs plugins. Now we know that it is with install, and here we've got the micrometer metrics plugin, and we are registering this with the app micrometer registry, which we start right over here, and we are saying that it is a Prometheus meter registry with the default configuration of Prometheus. And if we go here further down, we see that we also have drop wizard metrics, and we are applying this to our metrics micrometer get endpoint, where we can then respond with the app micrometer registry and a scrape of all of these metrics. We can call this physically, but because we have already installed these plugins, this is already available in our application. So that means that when we are starting the application, a lot of logs will be able to be read from the console, and we will see that in just a minute. But before we do that, let's continue with the further configuration of our Ktor service. If we go to configure HTTP, we will see that it has got the configuration of Swagger and OpenAPI in these two different routes. This comes by default with Ktor, and this only means that we can just read out the Swagger document that it generates in the resources of our application right over here in OpenAPI and then documentation.api. This gets generated at the beginning of the application, and then we need to manually change this unless we have a specific library that can do this automatically for us, similarly to what Spring OpenAPI library does already with the Spring framework, which automatically creates and generates the documentation for us every time we make changes to our application. So if we go further down into the configuration, we get now to the interesting part, which is the configure databases, the configure routing, and configure transmissions extension methods for application. This is important because right over here we've got all of the examples that we need to understand Ktor and the access to the databases. So first we go to configure databases, and here at the top we've got the first example that is generated for us in startktor.io. And here we can see, for example, that we first make a database connection independently of the connection that we have seen before, and this connection will simply connect to a Postgres embedded database. However, this method is misleading because if we go inside of it, and this has been automatically created for us, we can see that the embedded, when it's true, means that we are connecting to an H2 database and not to a Postgres database. You can see here that it connects to JDBC H2 mem, and it is an in-memory database, but it is of an H2 type. So that is the first part, how we connect to the database with this DB connection. But this DB connection, as we have seen before and I have mentioned, this works pretty much like the JDBC template that we are so used to when we are running queries in Spring. This is something that we use mostly if we cannot for any reason use the JPA framework in Spring for our queries. Sometimes they are a bit slow, sometimes it's difficult to make questions, whatever reason it is. If we don't find a way to use JPA queries, the Java Persistence API, then we can always use the JDBC templates, which is akin to using here the DB connection. In fact, the JDBC template uses connection, which is this one over here, which is part of the Java SQL package, which we already know. This one defines routes as well, and as we have seen before, routing is the way we use to define endpoints that we want to access. And we have seen before in the beginning of the definition of our application that we want to make this request with JSON payloads for the request and for the response. And here we've got a request to post CDs, we've got a request to get CDs per ID, and we've got requests to change them with put, and we've got a request to delete these CDs. The way this works is by using a service called CD service that we have seen here, and that is that when it starts, it defines all of these queries right over here, and in the init, it will first try to create a statement, which will then use the create table cities so that we can use it in our code. The problem with this is that everything is manual, which is in the same way, the same problem with the JDBC templates. We are creating a query called create table cities. In this case, we are creating a table, which is basically create table if not exists cities, ID, serial primary key, name varchar 255, population int. So it's just a table that will record the rows of name and population. So that means a city and how many people live in there. And then we have other statements, for example, to create a city. So then we use the insert city query. Then we use the read city, select city by ID. And then we use other queries. So this is no different than those prepared statements. The syntax is the same, and we are using the DB connection in the same way as we did in Spring. So this is the first part of configure databases. The second part is the one that uses expose. And expose is quite fun because expose, what happens with it is that it uses a way to create tables very much akin to when we use the Java Persistence API in Spring and we tell it to generate automatically the tables for us. It works kind of like an automatic TLL creation. And we have seen this in the beginning of this video very shortly, but now we can look into that in much more detail. So if we go inside the user service, we can see that we've got a definition of an object, which is users table. And here we define 3 different members of our object. These are ID, name, and age. It has a primary key and it extends from a table. We have seen before that table is just a simple table where we can then define whatever we want with it, but we are simply defining here that we've got a column of an integer type named ID and we are auto-incrementing it. But the way this starts is by using here init and creating a transaction that will then call this database, and then it will call schema utils and then create users, which is this object over here. And then we've got all the other different queries that we may want to use. One of them is this one over here. We create a user, an exposed user, which works pretty much like a DTO, and then we get that into a DB query, and then we insert. This comes out of the box with table, and then we insert this into the database. It is a row in our table, an insert statement, and this is another insert statement. So we say that for age, we use the user name, what comes in the DTO, the exposed user, for it, and then in age, the same thing. It is the column with type integer with name age that we can then use to set up the age in the database. And then we just simply say, okay, now we've done this, and now we return the user ID that has been created. All right, so this one is very similar. The read is the same thing. We are doing a select all where the user's ID is the same as the input ID, and then we map to the exposed user so that we can return an exposed user to our endpoint and then provide the data for our get endpoint. Important here to understand is that this does not run single-handedly. It is not that we are running a select all and then programmatically we are changing this. This all gets interpreted to run the query that is necessary to run against the database. When we run here the update, it's kind of the same thing. We are updating the user that comes as an input argument with a specified ID, and then what we do, we update the user's ID with the ID that is given as an input argument, and we then update the name with the username of the exposed user and the age, again with the user age of the exposed user. All right, so this is the update, and then finally with the delete, it's just simply a delete by ID. We again run the DB query, and then we go to users. We call from users the delete where, and then here we specify where the users.id is the ID. And DB query is something that we define over here with a suspend block, and then we just call a new suspended transaction, and here we are using dispatches.io, and then we call block, which is the function that we want to use, which is this one, or this one, or this one, or this one. These are all the different functions that we want to use for our CRUD, access to the database, which means create, remove, update, and delete. All right, so this is for the users, but I've added another one, which is another interesting part of it. But before we go into that, let's first see the second bit of this set of 3 elements that we have created in our application. So for routing, we can see that we are installing the server sent events plugin. We can check it out right over here, and we see here that this plugin is server sent events support plugin. It is required to be installed first before binding any SSE endpoints, and this is why it is located in the module of the application, the definition of the module of the application that we are going to use. Then we simply implement 3 different versions of the hello world command. Here we are calling respond text hello world just for a simple get. Then we are creating a server sent events endpoint just to send this hello data, which we are not going to use here in this video, but we will go into detail further in next video. And then here we also have another get endpoint with log, and here the idea is simply to use the hello service that we have seen before. The hello service is being injected at this point with this line of code. The hello service is declared this way: val hello service by inject, and then the hello service. The inject here is a delegate that will then be included in the Coin framework, and it will allow Coin to inject the hello service that we defined before in our configure frameworks extension function. And here we did create an hello service. Remember with the interface? That's the one. So if we go back to it and we see what happens, we are calling the say hello function, which will print out hello world to the console, but it will also return the text hello world. Finally, we are at the end of describing what this application does. We've got the configure transmissions extension function, and this will install one of the important aspects of this application that will remain here for next tests that we are going to do in coming videos. Now here the idea is that we are making the same kind of endpoint, in this case with only a get and a post request, and the idea is that we are saving transmissions that are being sent between 2 spaceships. This is a very basic beginning of the implementation of what this project is really about. And here what I'm trying to do is simulating the transmission of different requests between 2 different spaceships. So the idea here is that I send the transmission somewhere, and then I return the result of that transmission in a DTO, which is this one over here, which has an ID, a sender, a receiver, a message, and then it has a serializable with a timestamp. For the moment, I've got this implementation over here. It simply does a simple deserialization with the ISO local datetime formatter. This is important because this is how we can visualize our DTOs in the front end. And essentially, this is how the application is working. We have seen before how this whole thing works if we want to map our results from the database to the front end. If we, for example, have a look at send transmission, it will simply create a new suspend transaction, as we have seen before, and it will then insert and get the ID of our transmission. So we can see here, we are defining again the sender with sender, the receiver with the receiver, and then the message with the input message that we are getting here. So instead here of sending the whole thing, we are simply breaking down the sender, the receiver, and the message and sending them to the backend to save this message into the database. And the reason for that is that we want to check if the sender, the receiver, and the message have got values in them, because if they don't, we don't want to save this message into the database. So we are making here double checks and to see if we can get these results into the database. And then finally here at the end, and yes, I removed that run blocking, which was wrong. Now we get the response from the backend, from the database in a reactive way with the result of the send transmission, so the result of just saving it to the database. Of course, the rest is not yet available in our project, but it will be available soon. And then we've got here done the get transmissions, which is what we can then use to retrieve the results back to the caller. So now I guess it's time for us to make a demo of the application and see it all running, at least the aspects that we have seen before that are important for this video. So first things first, the hello world, and see if everything is working, if we get Ktor up and running. So I will just start the application first. We have got it running now, and I will just put this smaller so that we can see it correctly. And then we've got here the different HTTP requests that we want to use. So first things first, I've got it also over here in scratches and consoles. I've got here a scratch pad, which has a lot of different tests that I have already made available and ready to use. I will put this also in the project so you can try it as well. But the important bit here first is the hello world. And that one is located over here. It's simply a GET request to the root of the application, which is this one. And we've got an hello world. We can also do a hello world with a log. But first, before we do that, let's see what is happening in the console. As we can see, there are a ton of logs which are related to monitoring. Now, monitoring registers a lot of things, and it is important for us to understand all of this, what is happening, because it's registering things like garbage collection. Look at this, the Eden space, the old, the G1, all of this is being registered in the console. We don't need this for now. So now I will just restart the application so that we can run this test with the hello world. So if we go here to application, we can then disable monitoring. So we can now start our application. Let's do that, and we can see that our application has now started. And if we look at the logs, we are not getting now the pollution that we were getting from the monitoring plugin. What we are getting is the different logs that are important during the startup of the application. But an important aspect of these logs now is that we can see that we've got here the queries, well, some queries that are necessary to create some tables, but particularly using exposed. We are seeing only the logs of exposed. We are seeing the create table if not exists users, for example, and if you remember from our last example, there is another table. Do you remember which table was that? If you guess transmissions, that is right, because we can see that somewhere in these logs right over here, create table if not exists, transmissions. So we've got two table logs here in the console, but how do we get these here, and do these come here by default? Well, they don't come by default. Rest assured that we will not get any logs if we don't do anything special about expose. I wanted to show you this because I want you to see that when we are creating those objects in that very simple way, we are creating tables when we start the database. And we can see that because I have configured the logback log library to be able to see that. And if we go to the logback file, which is this logback.xml, we see that I have created an appender that will simply use this pattern over here, the typical pattern for the logs, and inside of it, I'm just simply logging everything that comes out of org.chatbrains.expose.sql. That's it. And then we can see in debug level what is going on with our queries. But that is an important detail about this, but not the most important one. What we want to have a look at now is how does the log endpoint behaves when we run our application. But for that, let me just restart our application in debug mode so that we can follow the endpoints and see what is actually happening in real time. So if we go to our file that contains the hello world routing, we can see all the different endpoints. And now what I want to do is create an endpoint here, an endpoint here. And now as we test the application, we will see where everything will go when we make these requests. So if I go over here and I try now the localhost 8080 log, then our request should fall into this bit over here. So let's run and see what happens. Exactly. So we've got them over here with the get log endpoint, and here we are simply just calling this service the say hello method. If you remember, this method is part of the interface, and we have implemented in our framework setup in here from frameworks, we have implemented here our service that simply uses as the default function implementation the environment log info hello world log. So we should see this in the console, but we should also see as a response the text hello world back. So let's see what goes on if I release this now. And so in our application, we should now see exactly the hello world text, and as a response, we should see hello world, which this is the response to the request that we just made. We can also do something different. We can try and use a GET request to get this SSE endpoint, the server send events. The thing is, we are not going to test this fully, but we can give it a try and see what we get from the console. So if I just simply copy this over to here and just say, hey, to the SSE endpoint, which in this case is hello, if I run this now, then we are falling into the SSE endpoint, and this will then send events to our stream, but this isn't something that we are trying now. We can just see that we have created an endpoint and it is accessible via a client. That's it. That's so far as we are going to go in this video when it comes to server send events. And this basically sums up our hello world routing. But the important bit, because this is just about Ktor, the important bit is how we deal with databases, of course. And we've got two different, or shall we say 3 different endpoints that we can use to make tests against the database. And so let's go first to the databases routing. Here we find the 2 different routes that we are using in this example. One is for cities and the other one is for the users, of course, which is this one right over here. Plus, this one is using an explicit user service, and the other one is just using a database connection with a city service that is also being declared explicitly in our routing. So let's now test cities. To test cities, I have, I think, an example already prepared for that. And if I go over here all the way up, I've got users. But I can also do this, cities. This is from a previous test that I was doing. So let's just say a city, for example, let's say Lisboa. And let's say population. Let's check how many inhabitants are there in Lisbon. So Lisbon population. So we've got these many people in from the census of 2021. Okay, that's fine. So let's put this over here. And let's send this and see what happens when we send this to cities. But before we do that, of course, I want us to put a breakpoint here into the post, into the get, and into the put, and into the delete. If I now send this and post it, it will fall over here as expected. But now what it will do, it will receive the city object from here. City in this case behaves as a DTO, as a data transfer object, and it will then be initialized here, and then finally we can then use it to call in our service the creation of the object. But if we go inside of it, we will see something that I mentioned before, something very similar, actually the exact way as the JDBC templates work when we use it in Spring. In this case, we just use a connection, we make a prepared statement, and then we set the different input values of our query, which is in this case this insert city, which has over here the name, population, and then the 2 different placeholders for the name and the population. And then it will check from the generated keys which was the last key generated. And then we can get in the first element the lastly generated key, or we can just say enable to retrieve the ID of the newly inserted city. This will probably never happen. This will, and we will get the ID as a response back to our client over here in this case with the status code created, which is the status code 201. After that, it responds with this and with the content of the ID of the newly created city. And we can see here in the response that what we've got is the status code and the message, which in fact is the payload of the response. So if I run this test now and let it go, we should be able to see that we've got a newly created city, and we will not see anything in the logs, of course, but we will see in the response that a new city has, because we took too long to debug. So let's just run it again and see what happens. So we just let it go now, and we should now see the response where we get 2, because of course we have already created a city, and the second city that we create then gets the ID number 2. So now what we can do is to retrieve the cities from the database. And if we do that, we can just go over here and just go to the generated requests, and here we should be able to get a city by ID. So let's get the second city that we created, because we have not created a call to get all of the different cities that we created. So we can just see just one. If we go here and then we just run this endpoint, we will get to get cities, and here we'll get the ID from the URL path value and use it to find our city, the city that we just created. Well, we've created 2, but we are now querying for city number 2. So if we run this one line further, we can see that the ID now should have number 2 in it. So we've got here number 2, city number 2, and it will read now from number 2. It is calling a method called read. Let's go inside read and see what happens. Inside read, we've got the select city by ID. We've got here the placeholder for the city ID. So we've got name, population from cities where city ID is something. Now, because this is all manually made, what we are doing, we select then where the where is supposed to find the ID with number 1, and then finally we get the name and population from the result set, which should just only have one result, and we return either the city or an exception if we don't find the city. But the problem here is that we are assuming that with this query there could be more records coming in, and this is a typical issue with using prepared statements, is that it is difficult for us in our code to specify if we are returning a list or not. And frequently you see these kind of constructions where we just see, okay, we're going to find the next value, and hopefully there won't be any more values in our query, which is logical because we are doing where by the ID. However, it is still not the best code. So here we already have some kind of code that is not the ideal, and that is purely because we are using just a database connection object for it. But if we continue with it, we see that it does work. And so if we look at the console now into results, we don't see anything here. We should see somewhere in our requests that, oh yeah, again, read timeout exception, too long debugging. So let's now do this again. And in this case, we will just simply run and let it go. So let's just run the same request again, the cities, and here we are. And then we just let the whole thing run. And when we get the result, we are now getting Lisboa with a population 545,142 inhabitants. And we get an OK request named Lisboa. So everything seems to be running OK in this case. We can also make the other requests, but those are easier to understand at this point, because now we do understand that, for example, an update will use the update city query, again, placeholders for the name and for the ID and for the population, because we are willing to change the name and the population. What we also see here is that there is one query to change the name and the population. So for example, if we wanted to update one record just to change the name or correct the city name, that would require different queries to allow that to happen. So here we already have another problem with using prepared statements, is that we need prepared statements that work with multiple different parameters. And of course, that's not an easy thing to do in our code. And then we simply have the delete method, which is simply just another part of the whole idea of CRUD, where in our repositories we just delete our object, although in this case we are just using a database connection for that. All right, so this is when it comes to city. Now, the first advantage we see with expose is, of course, when we use that, like when we use the JPA library in Spring. It's the same thing. We've got a different kind of construction for our example to exemplify that. So if we go here to databases routing, and if we go all the way down to the user service, now we've got again the user service being explicitly created, but the user service now uses expose. And expose means that we create objects that represent our table, and they extend from table, in this case, for example, just to create a table that we need. And we then specify this as an auto-increment column and this as a primary key, where we define the ID as our primary key. But let's see now, how does the endpoint work? So if we go here to generate requests and we go here to our cities example, now it is so similar that I prefer to just go here and just say user, and let's say we will get the first users, and then we will post to the users endpoint, and here we can say, hey, let's just put my name without the tilde, for example. And let's say here that for our user, let's go back to it. So our user has an ID, a name, and an age. So if we go here and say age, let's say that I'm 120 years old, for example. And let's just post this to our application. But before we do that, let's again get our endpoints debugged. So let's just go here to get, to post, to put perhaps, and delete. At least we will see that we will not fall into those endpoints. So if we now run this example, let's run the first example where we simply create the users. We will see that it falls here, and it will now use the user service to create the user. In the user creation, as we have seen before, it will insert the user and then it will return the user ID. As you can see, this is much simpler than what we did before, and it gives us the option to update or create a user with different fields, not necessarily all the fields. So for example, if the user that we are sending doesn't have an age, and in this case it would throw a null pointer exception, but say that this was nullable, then that means that we would be able to continue updating, or in this case creating our user with the same null here, and that wouldn't be a problem while creating our objects. And the same thing goes to the update queries right over here. If we want to update without a certain field, then we simply just don't use the field, so we can just not use it and then we're done. Or like this, and then we are done. So it's much easier to make updates. But let's see further how this example works. So let's just now continue with it. It will probably result in a timeout. I hope not, but I'm pretty sure it will result in a timeout. Yes, it will result in a timeout. So let's just run it again and see exactly what will happen. What will happen now, again, we will create two users. And let's now continue. And now if we look at the request, we should have a 2, exactly. Again, a 2 for the users, the second user that we created. So we can now just see if the users are there in our database. As we have seen, let's remind ourselves that these databases are at the moment in-memory databases with H2. So if we do a get now for user 1, for example, it will simply just read, as we have seen before, with the ID, and it will read this ID out of the path value, and then it will give us back to the client that user. And that's what we see in this get request over here. This user, João, who is 120 years old. All right, so this is a way to work with expose. Very simple, as you could see. And let's just go back to the database creation. As we have seen before, if we create a user service with a database explicitly, then that means that we need to call this transaction to create our database, which again is the database object, not the database connection, the database object. And then we can add a logger, for example, just to see the logs that are happening in a database when we call these methods. And then we can simply create the table users using the schema utils create users. All right, so that is one thing. But what we saw in this case was that we were creating a user service explicitly. Now we can do that, and that fits into different patterns that Ktor suggests for us. But we can also still use dependency injection in a way that is similar to the way Spring works. We create a coin context, and that coin context can then be used to inject our different dependencies. And that is what we see in our last example, which is a transmission example, where we can go here now to the route of those transmissions and see that we've got a get and a post request. In the get request, we are getting these transmissions. By the way, let me just delete this run blocking. It doesn't make sense to use it here. And then we can then get all transmissions, or we can post a new transmission where we then get and receive the requests this way with a map. It doesn't necessarily have to be a map. We can change this, but the idea is that we can send and receive anything we want with any different kind of key value combination. And then we can respond it and give it back to the client with the result of sending the transmission, which in this case only means putting it into the database. And that is what we see over here with the insert and get ID value. So this is just a shorter way to declare databases with an ID as a primary key. And let's remind ourselves what insert and ID does. It is created over here and defined in the int ID table, where the ID is a column with ID for name, because that's the default name that this int ID table gives to our ID column. Okay. Right, so now we've got the transmissions. Now we know a bit how this works. All we have to do now is just simply test the example. So let's just first post a transmission. Let's just simulate a transmission between two different spaceships. This is just the beginning of the application, as I mentioned before. So let's now see how that plays out. So if we go here to the example script or scratch file, we can see that we can post transmissions like this: spaceship A, spaceship B, hello from A. Let's just post this and see what happens. Now, we have already sent our transmission, and we can see that the response file has been saved here. We got an OK request, we got a 200, and we can now also see the response. But before I do that, let me just do one thing that I didn't do. If I go here to routes and I do here breakpoint on get and post, then we can see better where this is going. So now let me just repeat the example and just run it again, and we can see that in sending our request, it falls into the post. It goes right over here. We then check if all the fields are correct, because it validates if they exist or not, and then we send the transmission to our database, and it will respond with the result of that call. So now we've got two transmissions saved in our database, and if we look at what we just did, we will see that we've got ID 2, because again, it's auto-incremental. We've got ID 2, and what's important about this example is that we are able to do this because we are injecting our transmission service, which we have created before and declared in our frameworks file when we performed this configuration right over here at the bottom, when we created it with a database, with an in-memory database with H2, and then finally we created a single bean, a single instance, a singleton, that then we can use and inject in this way. So now we can just finally just get the transmissions and see if they have been saved correctly in the database. In this case, the embedded database with h2. So if we now call, let's put a get here, transmissions, then we fall into the get endpoint, and then here it will just call the get transmissions, which again, it happens within a new suspended transaction. It is probably not necessary in this case because it's only a select. We don't really need a transaction all the time, but this is just the example I have at this point, and then we just call a select all, we get everything in, and we map it to the DTO class following a part of the MVC patterns that are well known if you are doing applications with the Spring framework. So in this case, we are doing something akin to that, very similar to that. And then we can just let the code run. And then finally, we should now get in our get request, which one is it? This one. We get all the different transmissions from our database. So what we see here is something very important when using Expose, is that we can simplify our code a lot. You just saw how simple it was to create an insert, an update, a delete, or anything else with Expose. Well, we saw the get and the post. We saw how to select and how to insert data into our database, and how simple it is in comparison to just using a database connection in using prepared statements. The other thing that we saw is how to inject with coin. A very simple example, but I think it's a very efficient way of understanding how coin and Expose can work together for us. And you still have the choice of using injection this way. It's just a different way of using singletons in our application. It doesn't necessarily have to be this way, but it can work if you prefer to use this kind of framework or if you have a case to use it. The idea of this video was simply to introduce you to the idea of using Ktor and some things that it has to offer, a bit of the structure, a bit to understand how it works. I don't think conclusions should be made at this point about what Ktor is and what it can offer. It's just a way for us to have an open window to a very broad world that Ktor has to offer. In fact, I want to explore this further in a next video. And so in the next video, which will probably be next week, and I hope that the next week I'm able to do this on Wednesday at 5 p.m. CET, we will see if that's possible. But the idea is that the next video will incorporate Project Arrow, and we will incorporate all of the different patterns that Arrow has to offer in this video, again, under the theme of spaceships transmissions. This will be a video where we will change this application quite significantly, and these examples won't be available there anymore. I will put a tag on this project. It will be called tag 000, so that's easy to memorize. That 000 tag will be the point where this project was a broad and generic example so that we can understand better how Ktor works. In the meantime, I would advise you to know more about Project Arrow, and if you are up for it, I have made all of these different videos about Project Arrow, different topics. So one was optics, the other one was resilience, and this other one over here, so that you can learn the different aspects of using Project Arrow. If you want to understand more about reactive programming and coroutines with these kind of frameworks, I have a series, a multi-part 3-episode series from the beginning of this channel that you can see over here, which talks about how to make a reactive application using Spring and Kotlin coroutines. So I hope to see you in the next video. I hope this video was useful for you, and I hope you had a good introduction to what Ktor is and how it works and how can it work for you. Remember, we didn't touch the topics of coroutines yet in this video, just a little bit, but it will be something that will be the focus of everything in following videos. If this video was useful for you, if you enjoyed it, or if you've learned something from it, please let me know in the comments. Make sure to give us a like, and if you want to see more videos like this, make sure to subscribe to this channel, of course. Read the description, because there I will put all the different details and information about how this video was made, and also where can you find documentation and sources about how Ktor works and to start with Ktor. And until the next video, be sure to stay tech, keep programming, be kind, and have a good one. Bye. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.